Hi, welcome to my YouTube channel Education for Aspirants. Today I am going to discuss the concept of binary search tree. So in this lecture I will be covering what is binary search tree, the concept behind binary search tree, how to insert an element into the binary search tree, and at last we will cover how to write the Java code to create a binary search tree. So you know students, it is a very important concept for your university level exam and also for competitive exam, means those who are preparing for GATE and NET, that is very important. So maximum time the questions are coming from the concept of binary search tree. So keep watching till the end so that you will get all the concept of binary search tree including its development. So let's start the session with the concept of binary search tree. A tree is said to be a binary search tree if inside the tree the value of a parent node is greater than from all its left child node and lesser or equal from all its right child node. So let's see an example of binary search tree. So here in this tree the parent node are 20, 16 and 24, right? These are parent node. Why they are parent node? Because they have some child nodes, leaf nodes. So 20 has child node 16 and 24, 16 has child node 14 and 18, 24 has child node 22 and 28. That's why we can say 20, 16 and 24 are the parent node. Similarly 14, 18, 22 and 28, these are called as child node or leaf node. So in this tree if you will see, the value of 20 is greater from 16, 14 as well as 18. So what is 16, 14, 18? They are the left child of 20. Means you can see here the value of 20 is greater from all its left child nodes. Similarly 20 is lesser from 24, 22 and 28. And you can observe that the value of 20 is less from all its right child node. Hence we can say that binary tree is a binary search tree, because a binary tree is called as binary search tree if inside the binary tree all the parent nodes should be greater from all its left child node and less from all its right child node. So it is supporting, hence we can say that is a binary search tree. Now we will move how to construct a binary search tree. Before constructing to a binary search tree, I will tell you the rule how to construct. First of all, what you will do, so whatever the element you want to insert into the binary search tree, you will compare that element with the value of root node. So after comparing the element with the value of root node, you can decide that element, that inserted element can place so left side of root or right side of root. Clear? So this is only the concept. And like this, after deciding which side of the root it will place, you will move either left side of the root or right side of the root. That is the procedure. We will now insert all these given elements into the binary search tree. So first is 15. We will insert 15. Now to insert 15, you know that there is no element present till now in the binary search tree. So that's why whatever the element you will insert into the tree, that element will consider as a root element. So now we will make 15 as root element. Then after that 20. So what you will do, you will compare 20 with 15. Then you will decide which side of 15 that 20 will place. So if you compare, you will find out that 20 is greater from 15 and all the greater nodes should come right side of the root node. So that's why we will put 20 as a right child of 15. Now we will see 12, compare 12 with 15. So 12 is less from 15, that's why we will move in the left side. And though there is no element present in the left side, we will consider 12 as the left of 15. Next element is 16. Let's see. So if you compare 16 with 15, you will find out 16 is more from 15. That's why we will move in the right side of 15. When you will move to the right side, you will find again 20. So compare 16 with 20. So what you will get here? 16 is less from 20. So if it is less, as per the rule, the less elements should come in the left side of the node. That's why we will put 16 in the left part of 20. Then now we'll move 9. So same thing, same procedure you follow. Compare 9 with 15, you will get less. So though it is less, you will come to the left side. Then compare 9 with 12, again it is less. So though it is less, come to the left side, but in left side there is no node. Hence we will put 9 in the left side of 12. Then move to the 18. Compare 18 with 15. 18 is more from 15, that's why come right side. Then compare 18 with 20. So 18 is less from 20. Then come to the left side. So in the left side 16 is there. So compare 18 with 16. 18 is more from 16. That's why you put 18 in the right side of 16. Then next element is 14. So compare 14 with 15. 14 is the less from 15. Come to the left side. Then compare 14 with 12. It is more from 12. So though it is more from 12, that's why it should place in the right side of 12. So put it in the right side of 12. That is 14. Then come to next 4. Compare 4 with 15. It is less. Come to the left. 4 with 12. It is less. Come to the left. And 4 with 9. Again 4 is less. That's why come to the left of 9 and place 4 in the left side of 9. Then 7. Compare 7 with 15. It is less. Compare 7 with 12. It is less. Compare 7 with 9. It is less. Compare 7 with 4. 7 is more from 4. So that's why you should place 7 in the right side of 4. Then 10. So the last element. Compare 10 with 15. It is less. Compare 10 with 12. It is less. Compare 10 with 9. So 10 is greater from 9. More value from 9. That's why more value should be present in the right side of the node. So that's why you put 10 in the right part of 9. So put 10 here. Clear? Then in this way all the elements has been completed. Then see the binary search tree. In the binary search tree, all the parent node should greater from all its left child node and less from all its right child node. So if you will see 15, 15 is greater from all left side and 15 is less from all its right side. If you check 12, 12 is greater from all its left side and 12 is means less from 14. Similarly 20 is greater from 16 and 18 because 16 and 18 both are left side of 20. So in this way you can say that is a binary search tree. Now we'll move how to develop a binary search tree by using Java. So you know that tree in the memory, you can represent it by using linked list manner. So you know that a linked list is nothing but it is a collection of some nodes. For example, let this is a linked list. That is called a single linked list and this is called as double linked list. What is single linked list? Single linked list is the list which is the collection of some blocks where each and every block is divided into two parts. So you can see here in the single linked list each and every block is divided into two parts. One part is reserved for the information and second part is reserved for the address. Address of whom? Address of the next node. But coming to the double linked list, each and every node has divided into three parts. First part is reserved for, that is address for left node, address for means before node or left node. Similarly right side is reserved for address for next node. Clear? So now we'll decide to represent a tree in memory what type of linked list we'll consider. Either we will consider single linked list or double linked list. You know that when we are representing a node, that node may have two childs, left child as well as right child. So we need to represent two addresses. One is left child address, second is right child address for each and every node. Though we require to represent two addresses, that's why single linked list concept is not possible here. So what we need to do? we need to consider double linked list to represent a node inside the memory. I hope everybody clear about this. So to represent a tree inside the memory, we will consider a double linked list. Why we will consider double linked list? Because every node has left child node as well as right child node. Means every node to maintain two addresses inside the memory. So to maintain two addresses, you require to store two addresses in the block. So that's why we need to consider a double linked list. So with a single linked list, it is not possible to represent a tree in the memory. Now we will go for double linked list concept. This is the node of a double linked list. Clear? This part is called as left link part. This part is called as right link part. What left link part will hold? The address of the left node. Okay. What right link part will hold? The address of the right child node. Clear? This is left child node. And what the middle part? That is called as info. What it will hold? The element. Clear? The element. Now I discussed clearly every node required three parts. Clear? That's why what we will do, whenever we will declare a class, inside the class we will declare three variable, three data member to represent each and every space inside the node. Clear? Let's go. We will discuss a class here. Now we will take a class node. Then inside the node class, we will declare three data member. One data member is left link part, second data member is information part, and third data member is right link part. Clear? For each space, we will declare a variable here. And you can observe here, I declared left link part and right link part as node type. Why? Because these two parts will hold the address of another node. But we declared the information part as integer type, because I want to store a integer value in the information part. Hence I declared to that information part as integer type. But according to your requirement, you can declare the information part, right? Now this is all about your how to create a node inside the memory. Okay, or to create a node inside the memory, how to write the code. But it is not sufficient. Now we will write a constructor to initialize the node. Clear? So you know that whenever a node will create, at that time that for that node there is no left node, there is no right node. Means there is no left child, there is no right child. Hence you should make to the left child and right child as null value. So for this purpose what we will do, we will take a constructor. So though I have declared the class as node type, so I took the constructor name as node and I took a parameter that is int data. What is int data? Whatever the data you will pass as a parameter value, that data we will insert into the tree. Clear? So see here, I made the left link part as null and information part as data and right link part as null. If you execute this, it will create a node like this. Then it will make the left link part as null and it will make the right link part also null, and in the information part it will keep the item. For example, let you want to store 5, means that 5 will store inside the information part. Okay, but so still you have, means now you declare that, but till now it has not created the node. When you will declare the object for this class, at that time only the JVM will create a node. It will reserve a space for the node, and after reserving space it will do the work in that way. So now we will discuss how to create object for this class node. So we will declare node new node equals to new, then node item. What is item? Item is nothing but whatever the value you want to insert that node. Here 5 is your item. So for 5 we will create the node like this, node, new node equals to new, then node, in bracket we will write 5, then semicolon. If we do like this, then it will help to create a node, and the name of the node is new node. What is new node here? That is the reference. What is the reference? Reference is nothing but it is the name of the memory space which has been reserved. Clear? Let this is your object, and for this object the name is new node, that is the reference. Okay, so with this you understood how to create a node to insert an element inside the binary search tree. Now we will insert that node into the binary search tree into its respective position. For this purpose we will take a function, that is let void insert function. Then whatever the data you want to insert, that we will pass as a parameter. Then in the first step we will create the object. You know that if you create an object, then this object declaration syntax will help you to create a node inside the memory. Clear? And so this syntax totally I discussed in the previous before slide. Okay, so see here, if you write node new node equal to new node data, then it will create a node here like this, and it will store that item, means data part here, and the left link part is null and right link part is null. Clear? Now before inserting a node into the tree, there may be two conditions. One condition is either the tree is totally empty or the tree may contain some element. If tree is empty, there is no element present here. If tree contains some element, the tree may be looks like in this manner: 15, 10, okay, 12, sorry, that is 16. Clear? This is 10, then this is 18, like this that tree may be. Clear? Now if you want to insert an element, what you need to do? You need to compare the element from the root node onwards. If you compare that element from the root node onwards, you can decide whether that node, inserted node, will present in the left side or right side of the root node. And by confirming this, you will move either one of the side in the root. Let us consider the tree is totally empty. If tree is empty, what does it means? The root is equals to null. What is root? Root is nothing but this is the first node inside the tree. So if tree is null, means there is no root. If there is no root, means root value also null. So how will you know tree is empty? If you will check the root value. If root equals to null, then tree is empty. If tree is empty, whatever the node you will insert, that node will become the first node, right? So that's why if root equals to null, make root equals to new node. Make root equals to new node means what? New node is, this is the address of your element what you want to insert, right? So if you give the address to the root, then root will contain that address and it will become the first node. Let us consider you want to insert 15, means 15 will become the first node. Clear? Then second case is if tree has some existing element, then what you need to do? This is the second case. What you need to do? You need to compare the node, the value with the root node, then you will decide whether you will move in the left side or in the right side. So that's why I will take two pointers. One is PTR, second is parent. By using this pointer, two pointer, I will move in the either left side of the root or in the right side of the root. Now we'll process how to move in the left side and how to move in the right side. Means how to insert a node in the left side of a root node or how to insert a node in the right side of a root node. That we will discuss now. Let us consider first, we will insert a node in the left side. So when you will insert in the left side, if your item is less from the root node, right? If it is less, then you will insert it into the left side. If it is greater, then you can insert it into the right side. Let us assume that this your inserted item is less from your root node. So if it is less, what you need to do? You need to move in the left side of the root. Clear? So that we will write now. Now we will write PTR while PTR not equals to null. Why we wrote while PTR not equals to null? Because you will insert your item in the left side whenever you will get its appropriate position. What is the appropriate position? Appropriate position is nothing but when you will get a empty space. Okay, there you can insert that item. For example, let the left side of the node is like this, 8, then 7. Clear? Let you want to insert 4. Then what you will do? You need to compare 4 with 15, then you will move in the left. Then after comparing 4 with 10, again you will move in the left. After comparing 4 with 8, again you will move in the left. After comparing 4 with 7, again you will move in the left. Now there is no element present in the left side. Now what you will do? You will insert 4 in the left side. So what you understood from here? You will continue searching in the left side until you are not getting a null value in the left side of a node. That is the meaning. That's why I wrote here PTR not equals to null. So until PTR not equals to null, you continue searching. But when PTR equals to null, you will get, in that place you need to insert your item. What you will do now? PTR while PTR not equals to null, then inside the loop, first when you are moving into the left side, so you need to hold the parent node address also. Due to this, I took that parent to hold the parent node address. Clear? So parent equals to PTR. Why parent equal to PTR? See here. When you will start moving, at that time parent equals to null. Parent equals to null. And PTR equals to your 15. Clear? When you will move to left side, means you will come to the 10. At that time your PTR will become 10. But what the parent will hold? Because when PTR you will hold in 10, this node address you will not get again. Due to this, what you will do? First you store that PTR address in the parent, then you increment to the PTR. You move into the left side. Clear? That's why first I initialize the PTR value, means store the address of the parent node in the parent, then I moved in the left side. Clear? Next what you will do? If data less than ptr.info. Data means what? Your inserted item. What is ptr.info? ptr.info is that element where you are searching that node information part. Clear? So here in the first case, ptr.info equal to how much? 15. So data equal to how much? Let 4. What you will do? 4 less than 15. You confirm that you need to move in the left side of the node. Why? Because 4 is less from 15. So how you will move? What is the procedure? You need to increment to the PTR to the left side address. How will you increment? By writing PTR equal to PTR.left. Now PTR equal to how much? PTR equal to now address of 10. Clear? Then now you check whether PTR equal to null. No, PTR not equals to null because PTR is having 10 value. Clear? Not 10, some address. Clear? So if it is not means null, then again you will go to the while loop and you will increment to the PTR. Clear? So before incrementing, you will make that value as a parent, then now we will move to the left side by incrementing PTR. Okay? Here let us consider the address of 15 equal to 1, the address of 10 equal to 2, the address of 8 equal to 3, the address of 7 equal to 4, the address of 4 equal to 5, and there is no left value, that's why that is null. Clear? Address equal to null. Now we will move. When we will start moving, at first PTR equal to how much? PTR equals to 1. I hope understood. PTR equals to 1 because you will start from here. What is the parent value? Parent equals to null. Parent equals to null. Why parent equal to null? Because you know that, so parent will take the address of the means PTR. Whatever the PTR address is there, its parent address will store in the parent node. Parent means pointer. Okay. So here you are started from 15. That's why PTR equal to 1 and parent equals to null. Then when you will move from left means from the root to its left, PTR will become 2. But before becoming PTR equal to 2, first you need to assign the PTR value in the parent, then you will increment to the PTR. Okay. So what you will do here now? First you keep the PTR value in the parent, means parent will become now 1. Then check if data less than PTR info, then you will go to increment. Okay. Or you will update to the PTR value. Increment means update. Okay. So here data equal to how much? Data is your 4. Let you want to insert 3. Then check whether 3 is less than 15. Yes. Yes means what you will do? Parent will initialize with PTR value, update the parent with PTR value, then parent equals to PTR equal to PTR dot left. PTR dot left address equal to how much? 2. So now update PTR equal to 2. Clear? Then now you check whether PTR equal to null, whether 2 equals to null. No, 2 is address, it is not null, hence you will move to the while loop again. So now you will initialize parent equal to, means you will update parent equal to 2. Then check whether 2 of information equal to how much? 10. Whether 10 is greater from 3? No, 10 is, yes, 10 is greater from 3. So though 10 is greater from 3, what you need to do? You need to move in the left again. But if you will go to the left, so what you will write? The logic, PTR equal to PTR dot left. So if you will write PTR equal to PTR dot left, 2 dot left equal to how much? 3. So now update PTR equal to 3. I hope everybody understood. Now I will check whether PTR equal to null. No, PTR equal to 3. Then go to the while loop, again start from the beginning. So parent equal to PTR. Now parent will update with 3. Clear? Because previous value of PTR equal to 3. Now parent will become 3. Now, so 3 of information equal to how much? 8. 8. Check 8 with 3. Whether 8 greater than 3? Yes, 8 greater than 3. If 8 greater than 3, then what you need to do? You need to again move to the left. How will you move? By writing PTR equal to PTR dot left. So now new PTR value will become 4. Then check PTR equal to null. No. Then go to the up. Again initialize means update to the parent with the new PTR value. So parent will become how much? 4. Now check 4 dot info equal to how much? 7. So whether 7 is greater from 3? Yes, 7 is greater from 3. So if 7 is greater from 3, again you need to move in the left. Clear? So by writing PTR equal to PTR dot left, you can move into the left side. So what is the new PTR value now? 5. Clear? Now after updating to the new PTR, you check whether PTR equal to null. No, PTR not equals to null, PTR equal to 5. Then again move to the up. Then now parent equal to how much? Parent equal to PTR, means parent will become 5. Then check what is the 5.info? 5.info equal to 4, right? So check 4 with 3. So if you check 4 with 3, PTR.info is greater from 3, right? So that's why again you need to move the left. So in the left side, how will you move? By writing PTR equal to PTR dot left. Now new PTR value equal to how much? Null. Because there is no left of 4. Okay. Though there is no left of 4, PTR now having null value. Now check it. If PTR equal to null, yes, PTR equal to null now. So if PTR equal to null, what you need to do? You need to insert your item into the left part of its previous node. What is the previous node? That is 5. So in the left part of 5, you need to insert. So to insert here, where you will get the address of this node? You can get the address of this node from the parent. Yes or no? You can get it from the parent. So what you need to write here? By writing parent dot, I wrote here parent dot left. Parent dot left means this place. Okay. Parent dot left equal to new node. If you write parent dot left equal to new node, what it will do? It will insert your item into the left part of 4. I hope understood. So this is all about your how to insert a node into the left side of a root node. Now we'll means discuss if the inserted item is greater from the root node value. So if it is greater from the root node value, where you can insert? You can insert it into the right side of a node, right? So now we'll process how to insert that element into the right side of a node. You want to insert 20. So if you insert 20, what you need to do? Same procedure, you need to check 20 with the root first. If it is greater, then you will come to the right side. So at the beginning stage, what is the parent value? Parent value equals to null, null, and PTR equals to your start address. Let us consider the addresses are root node address is 1, 16 address is let 8, and 18 address is let 9. Clear? These are the addresses I assigned. Starting value of PTR equal to 1. Clear? Now we'll check whether PTR greater than 15 or not. Yes, PTR greater than 15. If PTR greater than 15, then what you need to do? You need to come right side. You need to move in the right side. What is the procedure to move in the right side? So you need to update to the parent first, then you will update to the PTR. In the while loop, you checked here if data less than PTR.info. What is the PTR info here? PTR info is 15 because you are starting from the root node. And what is your data? Data item is your 20. So data is not less than PTR.info. Data is more. So though it is more, you come to the else part, right? You need to come to the else part. So in the else part, first what you will do? You will update to the PTR. So how will you update? By writing PTR equal to PTR.write. So here you should first store the PTR value in the parent, right? Parent equals to now 1. Clear? Then you came here. Then in this part, PTR equal to PTR.write means what? PTR equal to PTR.write means 1.write equal to 8. I hope understood. Now check. If PTR equals to null, no, PTR not equals to null, PTR is 8. If PTR is 8, what you need to do? You need to go to the up. Clear? Again you will continue the loop. Before going to the means right side, again what is the first step? Parent equal to PTR. Now parent will become how much? New parent value equal to how much? 8. Right? New parent value equals to 8. Then check here, data equal to how much? 20, and 20 less than PTR.info? No, because PTR equal to 16 and your item you want to insert as 20. So it is not less. That's why you need to come again the else part. So in the else part, what you need to do? First you will write the syntax to move the right. Okay. How to move right? By writing PTR equal to PTR.write. Now new PTR write equal to how much? 9. So now new PTR will become 9. Now check whether PTR equal to null. No, it is not null. It is 9. Yes or no? That's why you will move again up. So in the off, what you need to do first? You need to first update to the parent. Parent equal to now how much? 9. Right? Then now check. So whether 20 data equals to 20, 20 less than 9.info. 9.info equal to how much? 18. Whether it is less from 18? No. 20 is not less from 18. 20 is greater from 18. That's why you will move again the else part. In the else part, you will write logic how to move in the right side, right? So to move in the right side, you need to execute PTR equal to PTR.write. So here PTR equal to PTR.write means how much it is? Now it is null because there is no write node present. So that's why new PTR value will become null. Yes, new PTR equal to now null. Then just check here, if PTR equal to null, yes, PTR equal to null now. So if PTR equal to null, you know that is the appropriate place to insert your item. So what you will do? Parent.write equal to new node. Means whatever the new item is there, new node is there, that you will insert in this place now. So we will insert 20 in this place. Clear? Then close the else part, close the while loop, then close to the function, then close to the program. Okay. So this is all about your how to insert an element into the binary search tree either in the left side part or in the right side part. Thank you.